Hey, Bogdan Brzeski here, another video, linear functions, horizontal or vertical line, which one? So what is it? How do you recognize and how do you put it together with other form of equation of a line? So let's dive into that. So you are most familiar with y-intercept slope form equation of a line, because it's very practical. It is very useful when we want to show a slope of a line, y-intercept. We want to do some modeling and see if the patterns are linear, rate problems. Beautiful application. However, this equation of a line does not allow you to create an equation of a line when the line is vertical. So that is a sort of a challenge for us to create a vertical line equation without using this particular form. The standard form that you're already familiar with is a beautiful form that is used in word problems, solving system of equations, and also it's very practical when it comes to identifying vertical line or a horizontal line that is supported with or comes with an equation, right? And then we have a less known equation of a line that is allowing you to identify strictly the x and y-intercept. And the only sort of challenge is here when the x or y-intercept happens to be at the origin. So that's obviously not a very useful equation because a coefficient and b cannot be equal to 0. Okay, so let's review the vertical line concept and the horizontal line. So a vertical line is not a function. It's an equation that defines a line that runs vertically, so it's parallel to y-axis. So what happens here, x is fixed. So any point on this line has the same x coordinate, but y coordinates can be any real number. So when you shrink, if you will, the standard form of the equation of a line, where x is the only fixed variable, and then from that equation you can solve for x, and there's only unique and one solution, right? So no matter what a is, so a is not non-zero integer. C can be 0 or not, it doesn't matter. But when solving this equation, there's only one answer for x and infinitely many possibilities for y, so that all those points would define a vertical line. Horizontal line, conversely, is a specific function, linear function, where the slope is 0. So there is no rise, no fall. So all points are horizontally located. So they are represented by the same y coordinates. So x can be any number, but y is always fixed. So hence the equation y is equal mx plus b. Since m is equal to 0, so it is reduced to y is equal to b. So the y-intercept is used here to describe a horizontal function equation of a line, or thinking of the standard form. So x is not considered to be a very important or critical value. So by component plus c is the standard form of that horizontal line. So when you solve this equation for y, you would get only one answer. Each time b and c changes its value, y will be uniquely identified. So this is the specific case for linear equations. Two of them are not necessarily linear functions. And in fact, vertical line is not a function. Horizontal line is a linear function. So that's the major difference. So let's look at this example where we just say, when I have x and y intercepts available, you can use this equation. You don't need to memorize this. You just need to understand that you can transform this equation into any other form known to you. Y-intercept slope form, or you can convert this equation into standard form. And also you have to be mindful that any form that you start with, you can create other forms as well by just changing and rearranging that equation. So for example, if you want to get from this all the way to slope y-intercept form, you would have to solve this equation for y. And you know how to do it, right? It's a linear equation. You have to rearrange. So you would move that term over to the right side. And then, because this is over b, so you would have to multiply both sides of this equation times b, where b is non-zero value. Then you get this form, which is essentially the slope b over a, negative b over a. So that's a rise over run. That's actually very well and nicely connected. So this is the conversion from that x and y-intercept into slope y-intercept form. Also, you can use this equation and say, if I want to do the standard form converting this equation, you would observe the following. Coefficients a and b are not necessarily the same. They can be equal in particular cases, but generally speaking, they're not. So you would multiply both sides of this equation by a times b, which is a common multiple. So right here, when you do that, you would eliminate the fraction expression because you would cancel the a from that product. You would reduce b from that product, and 1 times ab is ab. And then you connect everything together by putting x term first, y term in the second place, and then constant the third place. So this is the standard form of the equation because it's coefficient b, coefficient a. I know we call them differently in the actual sort of definition, but it is for you to observe that the pattern is maintained. We have x term, we have y term, and a constant value. Also, when you have a slope form that you want to convert into standard form, without paying attention to the value of m, you would say, okay, I can quickly rearrange it so that I have x term, y term in the second place, and the b term. So you have those three elements of a standard equation. Now, you would want to make sure that there is no fraction and m remains positive after you make the final changes. So if that was a fraction, of course, you would have to multiply by the denominator both sides to eliminate the fraction. If that was a negative value, then you will multiply entire equation by -1 or divided by -1, which is essentially the same thing, to get the standard form. So hopefully that makes sense now. And this is a visual representation of possible lines. And the first one is the mostly used, the slope y-intercept form. When you have that, you can easily identify x and y-intercept. Why is that? The y-intercept comes with this equation, so that's not a big challenge. But if you want to quickly identify the x-intercept, rearrange this equation so that you have x term, so 3x plus 1y is equal to 9. And to make 1 out of the constant value, you have to divide both sides of the equation by 9. So this is 1. And then you have y over 9. And there you go. That confirms the y-intercept is 9. We know it. And 3x over 9. So you can cancel conveniently this or that. Or divide it 9 over 3. Same thing. And you get 3. There you go. this is your x and y-intercept values quickly identified. Now, in terms of a horizontal or vertical line, a particular example, if the point on the line is 4 and y is 0, and this is to be a vertical line, then x is continuously equal to 4 for any other point. If x was to change its value, then the line would no longer be a vertical line. So x is fixed, but y can get any real number for its coordinates. And that is the case where the line cuts x-axis at that point 4, 0. This is the x-intercept. There was no y-intercept here, obviously. Now, in terms of a horizontal line, for example, y minus 5 is equal to 0. It's a sort of standard form of the equation. And when you solve it for y is 5. So y is equal to 5 could be misleading, like x is equal to 4. If you're not putting in the context of a straight line, you may think, well, y is equal to 5, it's a number. It is a number, but also it represents an equation if the proper context is provided. So y is equal to 5 means the second coordinate is fixed. It's always 5. However, x could be any other real number. And there's only one y-intercept for horizontal line, and this is a function, and vertical line is not a function, just to be clear on that. So you may get sometimes a question where you have a given point and you have to come up with a unique equation of a line which is either horizontal or vertical. One point is enough. So in case point P has coordinates x is 2, y is negative 7, and the question is find a horizontal line, so then you have to imagine that y coordinates for that point would be used for creating equation of a line. So you would say y is equal to negative 7, or thinking of the standard form, y plus 7 is equal to 0. This standard equation of a line would be more readily understood that this is the equation of a line, or this is a linear equation. When you say y is equal to negative 7, you would have to support it with the statement that this is the equation of a line, which is a horizontal line passing through negative 7 on the y-axis, and any other point also shares the same y coordinates. Vertical line using the same point, so you flipped sort of the concept. X is fixed, so x is 2, and y can be obtaining any other number. So 2 and negative 7 is given so that you can sort of anchor location of this vertical line. It is not a function. It is represented by an equation because it's a relation, but it's not a function. And you can use both expression x is equal to 2 and add information that this is a vertical line, or you can say x minus 2 is equal to 0 will be more obvious statement for the vertical line. So hopefully now everything is clear and you understand the difference between vertical and horizontal line. And before we go, practice question is a must. You should be doing practice questions all the time so that you solidify your learning. Thanks for watching. We'll see you next time.